This is the single most frequently asked SQL interview question across the entire data industry. Interviewers use it to test whether candidates understand null handling, tie-breaking semantics with ranking functions, the distinction between empty result sets and null values, and the ability to generalize a solution to the n-highest value. This is the single most asked SQL interview question across the entire data industry. Second highest salary. 4 words. Sounds trivial. But most candidates still get it wrong, not because they cannot write the query, but because they do not understand what the interviewer is actually testing. The question is not about finding a number. It is about whether you understand the difference between an empty result set and a null value. Let me show you the trap, why it breaks, and the pattern that handles every edge case. Here's the trap most candidates walk into. Order by salary descending. Limit 1, offset 1. Clean, concise. Works perfectly on the sample data. Returns 200. But now change the data. Give every employee the same salary. Run the query again. The result? Not null. An empty result set. 0 rows. The spec says return null if no second highest exists. An empty result set is not null. Your query just broke the contract, and most candidates do not even realize it. Let us trace exactly why this breaks. In SQL, an empty result set means 0 rows returned. Null means 1 row with a null value. These are fundamentally different. When your application code reads the result, 0 rows means the query matched nothing. 1 row with null means the query found a valid answer, and that answer is unknown. Downstream joins, coalesce expressions, and API responses all behave differently. The limit offset pattern has no mechanism to produce a null row. It either finds a matching row or returns nothing. That is the gap. 2 fixes. First, the scalar subquery wrapper. Take the exact same limit offset query and nest it inside a select. When a scalar subquery returns 0 rows, SQL automatically coerces the result to null. One line of wrapping converts the empty set into the null value the spec demands. Second, the dense rank CTE. Rank every salary in descending order using dense rank. Filter where rank equals 2. Wrap the result in max. If no rank 2 exists, max of an empty set returns null. This approach is cleaner, handles ties explicitly, and generalizes to any n-highest value. 4 edge cases to defend. First, all employees share the same salary. No rank 2 exists. Dense rank assigns rank 1 to every row. Max of an empty filtered set returns null. Contract satisfied. Second, only 1 row in the table. Same logic. No rank 2. Max returns null. Third, multiple employees share the second highest salary. Dense rank assigns the same rank to tied values, so the filter returns the correct salary once via max. Fourth, null salary values in the source data. Add a where salary is not null guard before ranking to prevent nulls from corrupting the sort order. Lock this pattern permanently. 3 rules for n-value problems. Rule 1. Scalar subqueries return null when empty. Use this to satisfy null contracts without changing your core logic. Rule 2. Dense rank preserves ties without gaps. Use it over row number when you need the n distinct value, not the n row. Rule 3. Max of an empty set is null. Wrap your filtered rank in max as a safety net. These 3 rules turn the second highest salary into a fully generalizable n highest salary pattern. Change the rank filter. The rest stays identical. Let's analyze the order by plus limit offset broken approach. Time complexity, O of n, log n. Space complexity, O of n, requires a full sort. Returns an empty result set instead of null when no second highest exists. Breaks the null contract. Let's analyze the nested max subquery approach. Time complexity, O of n. Space complexity, O1. 2 sequential max scans. Returns null correctly, but requires 2 full table passes and does not generalize to n highest. Let's analyze the dense_rank CTE optimal approach. Time complexity, O of n log n. Space complexity, O of n. Single sort pass. Handles ties, returns null via max wrapper, and generalizes to n highest by changing the rank filter. The interviewer will then ask, how would you generalize this to find the n highest salary? Replace the rank filter from where rnk equals 2 to where rnk equals n. The dense_rank CTE pattern handles any rank value without modifying the query structure. Wrap in max to preserve the null contract for any n. The interviewer will then ask, what is the difference between rank, dense_rank, and row_number for this problem? For salaries 300, 200, 200, 100, row_number assigns 1, 2, 3, 4, choosing arbitrarily between tied values. Rank assigns 1, 2, 2, 4, skipping rank 3 after the tie. Dense_rank assigns 1, 2, 2, 3, no gaps after ties. 4. Second highest salary, we need dense_rank because we want the second distinct value, not the second row. The interviewer will then ask, can you solve this without window functions? Yes, use a scalar subquery. Select distinct salary from employee order by salary DESC, limit 1, offset 1, as second highest salary. When used as a scalar subquery in the select clause, the outer query returns null if the inner query returns 0 rows. This leverages SQL's scalar subquery null coercion rule.